I'm from Singapore.
From Vietnam.
AWS User Group Thailand.
I'm an AWS community builder.
I run the user group in Singapore as a community hero.
I'm an AWS community builder.
I love AWS community.
Go AWS.
I'm so proud that all the group members are very proactive to support each other.
I'm really passionate about making artificial intelligence and machine learning more accessible.
I'm also one of the AWS machine learning heroes around the world.
It's a global, positive and diverse community.
ผมเป็น Amazon Web Service Community Hero ประจำประเทศไทยนะครับ
The love of the technology and the friendship in the community.
Go AWS.
AWS is the world's most comprehensive and broadly adopted cloud platform. Millions of customers trust AWS to power their infrastructure and applications. Organizations of every type and size are using AWS to lower costs, become more agile, and innovate faster. AWS provides on-demand delivery of technology services via the internet with pay-as-you-go pricing. You can use these services to build and run virtually any type of application without upfront costs or ongoing commitments. You only pay for what you use. AWS gives you more services and more features within those services than any other cloud provider. This makes it faster, easier, and more cost-effective to move your existing applications to the cloud and to build anything you can imagine. From infrastructure technologies like compute, storage, and databases, to emerging technologies such as machine learning and artificial intelligence, data lakes and analytics, and Internet of Things. Building on AWS means you can choose the right tool for the job. For example, AWS offers the widest variety of databases that are purpose-built for different types of applications. With AWS, you can leverage the latest technologies to experiment and innovate more quickly. We are continually accelerating our pace of innovation to invent entirely new technologies you can use to transform your business. Like pioneering the serverless computing space with the launch of AWS Lambda, which lets developers run their code without provisioning or managing servers. And AWS built Amazon SageMaker, a fully managed machine learning service that empowers everyday developers and scientists to use machine learning without any previous experience. We are constantly expanding our global network of AWS regions, so you can access AWS services to build and run your applications from anywhere in the world. Each of these regions has multiple availability zones that are physically separated from each other and connected by low latency, high throughput, and highly redundant networking. This makes it easy to design and operate applications that are scalable, fault-tolerant, and highly available. Our infrastructure is built to satisfy the security standards of the most risk-sensitive organizations. You also have access to the AWS Partner Network, which has thousands of systems integrators who specialize in AWS services, and tens of thousands of independent software vendors who adapt their technology to work on AWS. With the largest community of customers across every industry, AWS has unmatched experience and operational expertise you can depend upon for your most important applications and every imaginable use case.
You've earned an AWS certification. Congratulations! Now what? Show your employer, colleagues, and your customers that you've met the bar set by AWS experts. Add your digital badge to your professional profiles and email signature to highlight your skills. Share it on your social feeds to celebrate with your network. And offer verification via email or on your resume. Cloud skills are in demand, and you have them. Share your AWS certified achievement today.
Welcome to AWS Educate's Cloud Career Pathway. AWS Educate helps you create a pathway into innovative and lucrative opportunities in the rapidly expanding cloud industry. On AWS Educate, you will discover the skills necessary to advance into cloud careers, explore content, test your knowledge, seek micro-credentials as badges and certificates of completion, and even have the opportunity to apply for jobs and internships in the cloud. Start off by building your profile, adding your resume, classes, degrees attained, and other facets of your experience. Then, select a cloud career field. From there, we'll personalize your plan by providing content that matches your pathway. As you consume that content, we'll prompt you to take knowledge checks of 3 to 5 questions in order to gauge your comprehension. After you've completed 50% of the knowledge checks, you'll have a chance to earn an AWS Educate badge. Then, up-level your profile by completing a project and a final assessment, and you can receive an AWS Educate certificate of completion. Take applicable courses at your school or online to grow your knowledge and fill gaps in your skill set. All of these achievements can be added into your portfolio. Then put it all together. Apply for a job or internship at Amazon or at one of our customers or partners through the AWS Educate job board. Download your portfolio and send it to your potential employer to get your ideal job in the cloud. So what are you waiting for? Start your career pathway today.
Hi, I'm Amilcar with AWS. If your organization relies on Windows-based applications to run the business, your developers can continue to be as productive and effective if they develop applications for AWS. AWS provides tools developers can use to manage AWS services and Windows applications, empowering them to easily develop, debug, and deploy .NET projects. You can easily get started quickly with the AWS SDK for .NET. The SDK helps take the complexity out of coding by providing .NET APIs for AWS services, including Amazon S3, Amazon EC2, Amazon DynamoDB, and more. In addition, the AWS library provides numerous templates and resources to get your project started. The SDK comes pre-installed with any Windows instance and can be downloaded from NuGet or installed using the MSI package. It also includes the AWS Toolkit for Microsoft Visual Studio and the AWS tools for Windows PowerShell. Lastly, with AWS, developers can deploy at scale using AWS Code Deploy with autoscaling, and deploy applications using CloudFormation templates that help you easily deploy and manage solutions. You can also simply upload your code and Elastic Beanstalk automatically handles the deployment, from capacity, provisioning, load balancing, and autoscaling to application health monitoring. When your developers work with AWS, you don't lose a beat in productivity and your investments and skills can be applied immediately.
Hello, good evening everyone. Magandang gabi sa inyo lahat. And if you are wondering, why the hell am I watching AWS stuff on a Microsoft org channel? Yes, so tonight is a very special night for us because tonight's event is in partnership with AWS Siklab Pilipinas and AWS User Group PH. But before we go to our topic, which is orchestrating .NET containers on AWS. So we just like to go ahead and thank our friends and our sponsors that have helped us make this event possible tonight. So first off is again AWS Siklab Pilipinas and AWS User Group Philippines. Please visit them in their Facebook pages. They are the premier group of AWS, a premier community of AWS practitioners, experts, students, and professionals alike are in the group, and they'll welcome you in whatever level of AWS proficiency that you have. So. We are very, very grateful to them for making this possible. I have always wanted to have an AWS topic on on PHINUG. So it's great to finally have this partnership come into fruition, and with a speaker who's been an expert in .NET for a long time in the community. So thank you very much. And yeah, we'd also like to ask everyone to give their feedback later on in the show. We will flash this QR code again, but we would appreciate your feedback after this event. So please tell us how you felt and what you think about the event after our speaker has given his talk. All right. Following that, we again like to thank my employer, PHINUG. They've been helping me organize this event, and yes, we have openings in my team. So if you want to join me and together we will conquer the galaxy, please visit popcareers.phppeople.com. We have some developer openings in the Philippines. And yeah, off the top of my head, you're going to ask, is it completely remote? Yes, we are completely remote at the moment, and we're not really planning to go into the office full time. All right. And then finally, and most importantly, the .NET Foundation. We'd like to thank the .NET Foundation for hosting this event. We are in their YouTube channel, the .NET Foundation YouTube channel. They made the streaming possible, and they're working to support a lot of .NET. Actually, all of the .NET user groups around the world. They're the number one supporter, giving us resources like talks and access to speakers and hosting for live stream like what we're doing now. And if you'd like to watch other user groups from around the world, whether it's from the US, from India, from Bucharest, from Sweden, there's a lot of different events that are happening around the world at all time zones. A lot of them are in English, don't worry. So if you'd like to see those, please join the .NET Virtual User Group at meetup.com/.net-virtual-user-group. Yes, and this is the meetup that is being run by the .NET Foundation to support all the the various .NET user groups around the world. And then finally, of course, if you have not, I'm pretty sure you have gone through some of the through one of these channels, but if you have not joined us in our social media channels yet, please check them out, do so, and join us. I'm encouraging all the professionals to join the LinkedIn one in particular, because once we hit a certain number, currently we are only at about 70 members. That's too few. At around 150 members, we'd be able to stream to LinkedIn straight. So that might be a good thing for some people who don't want to jump across YouTube, or find YouTube distracting, or don't have Facebook, for example. So yeah, it would be great if you could join that as well. All right, that is it for my thanks. And just to introduce you to our next speaker, I've kind of known him as an online acquaintance for some time, and I've always had, even during the time pre-pandemic when we were having live events for PHINUG, I had always wanted to invite him, but I don't know. I think we just never got around to doing it. But I'm really happy that now, during this period where, yeah, we're kind of exiting the pandemic, but kind of still into it, we have the opportunity to have him on our live stream. So he's a prototyping architect. I will ask him what that means later. For AWS ASEAN, please join me in welcoming Richard Neil Ilagan, or as the community belovedly calls him, Carding. So, hey, Carding,
Hi,
thank you.
John.
Yeah,
Oh,
thank you
thank you
for
for having me.
being here. Yeah, yeah. So, what is a prototyping architect in AWS?
Yeah, he's in AWS, a prototyping engineer or a prototyping architect is a kind of a special kind of solutions architect. So
Okay.
if you haven't heard of solutions architect before, what we normally do is we provide recommendations to customers or communities. They have a problem, we can give them best practices or recommendations. A prototyping engineer kind of takes that one step further. We actually build stuff as kind of experiments.
Oh, okay,
So
okay. And help your clients out. All right, all right.
yeah,
I'll not let that a question take too much of our time. We can I'll hand the floor over to you, and we can start with our topic for tonight. So yeah, I'll see you
all
later,
right.
Carding. All right.
Sure, I'll see you later. Hello, everyone. Thank you for having me. I think it's my first time talking. Yeah, just like John said, it's my first time talking with the Philippine.NET users groups. I've known of the group for some time. Me and John used to talk about the group and how he's been spearheading the community for a while now. So I know it's a really really good community. I'm really excited to be here. Um, for tonight, I'm going to try to talk your ears off about orchestrating .NET Core containers on AWS. I'll try not to be too technical about it. I'll keep it at a very high level, at a relatively high level. I'm going to assume that not everybody in the session knows how to create a container or what a container is or what it is for, right? So we'll kind of start from a bit of the basics and then push forward from there, right? If you want to dive deeper into anything that we're going to be discussing today, like if you want more detail, you want more technical detail or something, please don't be shy to pop your question into the chat. We'll be reserving some time later for a bit of Q&A. Okay? All right, cool. So just a bit of a backgrounder for myself. John shared that I am a prototyping engineer for AWS here in ASEAN. Before I was at AWS, I was a pretty kind of straightforward .NET practitioner myself. So I used to work pretty much completely in .NET. I kind of stopped with that a few years back around when .NET Core 1.1 came out. So that was really the last .NET version that I've used. So I'm going to be jumping into .NET a bit today. I'm going to be a little bit rusty, so please don't hate me for it. But yeah, I'm going to try my best. Okay. So cool. The stuff we're going to be talking today, just very, very simple. So we'll talk about essentially what containers are, what they're good for, as just a bit of an introduction. And then we'll go right directly into how do you create a container using .NET Core. Like, for example, if you have an application using .NET Core, .NET 6, I don't know what's the official name now. How do you start containerizing that? And once you have a container of your app, how do you use it? And then eventually, how do you bring it to the cloud? How do you run it on AWS, for example? So I'll give you 2 examples later about how you can use a container to run it on AWS. Okay, sounds good? All right, cool. I'm sure a lot of some of the people that in the chat know what a container is, or at least you've worked with a container before, right? For the people that don't know what a container is, I kind of like to think of a container like it's a standard way to kind of package an application or an executable or a tool so that you can bring it pretty much anywhere, and then you can you don't have to install it. It will run anywhere containers can run, right? So one of the bigger problems that containers solve is that, and I'm sure a lot of the programmers here can relate, is that if, for example, I'm a programmer, I'm an engineer, I'm building something on my laptop, and then I bring that to somebody else's computer, sometimes it doesn't run the same way, right? For a number of different reasons. So containers are a good kind of solution for that, because once you package an application inside a container, you can bring that container pretty much anywhere, and anywhere containers will run, that application will run pretty much virtually the same exact way. So you don't have to think about installing dependencies. You don't have to think about how you should prepare the environment and so on and so forth. It will always run pretty much the exact same way, which is very, very convenient, right? Aside from that, there's a lot of different benefits with containers. A few years ago, I used to say that containers are really, really, really great. It's a very, very good technology to start learning about, because a lot of places, a lot of use cases, a lot of companies are looking for ways that they can use containers. Different ways, so many different ways. These days, I'd say that they're pretty much a staple. Like, if you don't know how to use containers, if you don't know how to actually build with containers, you're kind of missing out, because there's a huge, huge, huge field in technology where containers are very, very valuable. So if you haven't tried containers before, I really, really recommend you try to start learning about it. At least, at least, just getting started with how you use containers, because it's a very, very important technology. A lot of places, a lot of different problems, a lot of different solutions and services use containers for many different ways. For example, before, when I got started with containers are pretty much used for web servers, for example, because I'm a web developer myself before. We used containers largely for running web servers or backend servers. Now there's a huge amount of places where you can run containers. They're used in IoT. They're used in machine learning. They're used in your CI/CD or DevOps. They're used in big data, data processing, and so on and so forth. There's a lot of different uses for it. I'm not going to kind of exhaust why it's very, very important, like containers as a technology, why it's very, very important. I'm not going to go into that. But suffice it to say that containers right now, in pretty much any industry, no matter what kind of engineer you may be, it's probably in your best interest to take a look at how you can use containers one way or another, right? So today I'm going to try to demonstrate how you can kind of use containers for .NET Core apps or .NET 6 apps, for example, right? So let's give that a shot. So I'm not going to give you a lot of slides. Let's just go directly into coding, okay? Let's see. So, oops, there's my Yan cat. Okay, cool. So what I prepared for you, hopefully you, everyone can read the text in the screen, right? What I prepared for you is that I've got a very, very simple ASP.NET actually. So as you can see, all the files are pretty much what you'd expect from a pretty much bare bones web app, right? So I'll tell you how that looks now. Pretty much, if you've created a .NET Core app before, this is pretty much just a web API template. I've added a few controllers of my own. So this is how the first controller looks. Let me try to zoom that out for you. So like I said, it's a web API application. So what I've done is I've created an application that has a few endpoints that allow me to compute a hash of a string. I'm using the SHA-256 algorithm. So the idea is you give a text, you give a string, you give some text, and then the API will give you the SHA-256 hash of it, right? So it's pretty nothing special here. It's just a .NET app. I've got a controller right there, and then I'm providing a route. So that's my controller action right there. And then this is an HTTP GET under that route, right? So far, so good. And then within that controller, I'm sending an input. This is the text. This is your piece of string. And then I'm just calculating the SHA-256 hash. that part is really not important. What I'm trying to show you here is that this is, just your normal .NET app. Cool. Okay, I'll show you how that works then. So now I have a .NET app. Let's just see how it runs then, right? So if I run it like this, then it should give me, there we go. So this is an ASP.NET app. It runs a server on my machine. It's made my web API available over on that port. Cool. So far, so good. All right. Let's try talking to it. So I opened another terminal below it, right? So nothing special. My server is still running on top. I'm just showing you that the .NET app works, right? Let's try talking to it. So I think this is how you do it. Oh, whoops, sorry. 127 5030. There we go. So if I talk to my controller, I think it's hash SHA-256, but I created, right? Let's do like PHINUG, right? Something like that, right? There we go. So it gives me, I give it an input, and then it gives me the SHA-256, right? Nothing very, very special. So far, so good. It's just, point is, this is your run-of-the-mill. It's a normal .NET app. It can be any .NET app that you're currently working on. What I have now is something very, very simple. Okay, let's stop that. Now, we have a .NET application. Let's talk about creating a container with it, right? How do you create a container from a .NET app, right? So if you haven't created containers before, you normally create a container using a set of instructions in a file called a Docker file. So let's do that now. Over here, I'm just going to create a file called a Docker file with a capital D by default. All right, cool. One of the nice things about a Docker file is it's really just very, very simple to understand. It's just, like a step-by-step instruction. Step 1, do this. Step 2, do this, right? I'm going to, just to save us some time, I'm just going to paste all my instructions like this, right? I'll explain these in a bit, but bear with me for a moment. So the important things to remember is that if you're creating a container, whether it be .NET or Python or Node.js or Rust or whatever programming language you're using, to create a container image, you use a file called a Docker file. And a Docker file is just a set of instructions, step by step, right? Now, once you have this, all I have to do is go to my terminal again, and I just ask Docker to build it, right? So Docker build, I want to give it a name. Let's call it .NET container. So why not, right? And then once I do that, it's going to provide me, it's just going to build the container for me, right? Now, whoops, did that work right away? Oh, cool. All right, cool. So now that my container is done, I can just see it right there. I now have a container, right? So far, so good. Remember, if you have any questions, just put them in the chat and then I can go back to it later, okay? So now that I have my container like that, I can actually, there's a number of things I can, that I can do to it. I can run it, right? I can share it. I can send it somewhere. I can modify it, or I can even inspect it, et cetera, right? So if you remember me saying earlier, what are the benefits of a container? One of the very real benefits of it is that this container, wherever I take it to another computer, whether that be on the cloud or my colleague or my friend, my workmate, my boss, or no matter what server, right? No matter where I send or bring that container will pretty much run exactly the same way, right? Let's try that now. Remember when I ran the .NET app earlier? Let's try doing that with a container. So this is my, whoops, sorry. Again, this is my container, my image, actually an image. Let's run that. You do that by Docker run, by just saying Docker run. And then let me just put in a few things here. I'm saying all of these gibberish. I'm not going to bore you with what they mean, but what I'm really doing is I'm just running it and then making sure that it doesn't, it doesn't clutter my machine, right? And then I want to run my .NET container. Okay, so if I did that correctly, what's going to happen is that that container is now running on my machine like that. So you can see here that I've got a container running. It was created 6 seconds ago. And then that container is currently forwarding some of my network ports like that. So now I remember earlier when we ran the .NET app, it was on port 5030. This one is on port 80. So if I do the same thing, there we go. So I can actually talk to that same machine. Let me show you how that works in a browser. Localhost, there we go. So that's my container right there. Hash, 256, PHINUG, right? And then there we go. So I can talk to the .NET app because it's running inside the container. And that is my container right there. Like that, right? So now, since it's running, I can, just like any application, I can Docker stop it. I can use that container ID right there, DF. And then now I don't have anything running anymore. So now I go to my browser, I reload it. It's unable to connect because I don't have the API running anymore, right? Let's run it again. And I'm back up. Just to show you that I'm not pulling your leg, right? I'm actually running a real app inside a container, right? So that's how, that's kind of the crash course kind of gist on how containers work, how you can build a container, how you can stop a container, how you can use and run a container, right? So remember when I said earlier that this is the Docker file. So this is the set of instructions about how you can actually build a container, right? There's a very, very good documentation about what the Docker file does on how to write a Docker file over at the docker.com documentation site. But some of the more important things I'd like you to notice here is, number one, I'm actually using an official .NET container image here. So let me show you something. You can actually use any image or any Docker image you have as kind of like a starting foundation for any of your containers. So if you want to build a container like this, right, you've got to start somewhere. You have to start from a foundation, and then at least on this Docker file, I'm using the official .NET SDK image from Microsoft. So I can use any image. Right now, I'm just using this. So if you go to the Docker Hub, that's just hub.docker.com, you'll see something like this. There's a lot of different images there that is ready for you to use. So no matter what you're building, whether that be, again, a .NET app or something else in another programming language, or you want to use something more tangible, like say this, a Postgres database, or maybe a Redis cluster, for if you want to create one, right? You can always find one of those images over here and use that as a foundation. So in this case, I'm just using the official .NET base images. So they have a number of base images over there, right? I'm actually using the .NET SDK so that I can compile my application. And I'm using the second one, which is the ASP.NET image to run the application. So again, my Docker file looks like this. This is the official SDK image. And then here is the ASP.NET image, which I'm using to run my application. Okay. Again, in the interest of time, I'm not going to explain everything about the Docker file. If you want to learn more about it, there's a very, very good documentation about it right here in the Docker website. So please do check that out. If that sounds a little bit too complicated, just remember that a Docker file is just a set of instructions. It's just, step 1, step 2, step 3, step 4, and so on and so forth. It's really just, following a series of commands, right? It's not too complicated once you get started. Cool? Cool? So far, so good? Again, that's my image. So now, at this point, we now have a container, right? We have a container. I can use that to run my application. So imagine this is your own application. You have your .NET application somewhere, and then you created a Docker file. You created the container image for it. Now you have this. When you do Docker image, you have, my .NET application kind of image, right? You already have that. The question now is, how do you then use that container or container image to run it on, say, the cloud, right? Or how do you run it somewhere else? How do you take this image and bring it to a different computer, to a different virtual machine, and so on and so forth, right? Most of the time, the easy way to do that, if you want to share, if you want to bring your container somewhere else, if you want to send it somewhere else, right? The easy way to do that would be to push that container to a repository, just like how you do it with Git. So if you know Git, you probably already know how to do what I'm talking about. You can push this image to an image repository. So if you're starting out with Docker, Docker Hub is actually an image repository. That's why you have all of these images here. People are putting their images on Docker Hub for other people to use. Docker Hub is pretty much a repository, a public repository that you can use, right? So if you create your containers, your container images, you can push them right up here. Now, most of the time, you want your repository to be private because once you put it on Docker Hub, most of the time it's going to be public, right? Everybody can use it. So what if I want a private repository? What if I want to collect all of my images just for the use of my company or for my community, right? Or for just me and my friends, for example. That's where you go and create a private repository, right? So Docker Hub has a private repository. So if you create an account, you can create private repositories there. But let me show you how you can do that on AWS. Okay, so oops, this is my AWS console. So this is my own AWS account. If you've never used AWS before, this is what you see when you go into AWS, the AWS Management Console, right? If you've never used AWS, some tips when you're using AWS. Over here are your services. So you can click that and go to any of the services available to your AWS account. There's quite a bit. There's, I think, more than 200 AWS services now. Over on this side, the other side is your region. So just make sure that you're in the right region. Right now, I kind of want to use Tokyo because I'm feeling very Japanesey today. So I'm going to do Tokyo instead of Singapore. So just make sure that I'm in Tokyo like this. Like I said, there's a lot of different services on AWS. So one of those services is called ECR, this guy, Elastic Container Registry. Now, Elastic Container Registry, or ECR for short, is a container image repository. So you can use it to create a private image repository, for example, or even a public one. If you want a public one, you can also create that as well. So let's do that now. Let's create a repository to put our container in. Okay, so once I'm here, just get started, or you can go here on this side with repositories. I'll just go over like this. Some configuration there. A lot of the defaults are good enough. You don't have to change. One of the things you have to give is you have to give a name, right? So remember our Docker image like this. You can name it anything you want. I'll just name it the same way, the same name, just for it to be simple. But you can name it anything you want, right? Cool. So I'll just name it .NET Container as well. There we go. I'll zoom that in just so you can see. So I'll just name it .NET Container like that. And then that's pretty much it. You can go into any of the other configurations here if you'd like, but that's pretty much the only thing you need to do. So just give a name, and then you get a repository like this. Now, that repository, I can click into that, right? And then I can then push my image here. I can put my container image here. Right now, there aren't any images. That's why there's no images like that. If you want to push a container image, all the instructions are right there. So you can just click that and just do those 4 steps, right? So this first one, I'll just go through them one by one, okay? I'm not going to explain a lot of those, but this first one is just logging you in to your AWS account like that. So you should get a login succeeded like that. It's just logging in Docker so that it knows about your AWS account. It knows that you're talking to Tokyo, and it knows what your repositories are, right? After that, I've already built my container, so that's no problem. This third one, I have to use a different tag like that. I'll show you what that does. So if you've never worked with containers before, and this is a kind of a complicated thing, especially for people new to containers, right? If you've never used containers before, an important thing to remember is that the name of the container is always the URL where the container image is, right? So that's why I had to name my container like this, because this is the exact URL where my container is. Now, the thing is, if your container name is not a URL like this, the second one, right? That defaults to Docker Hub. So Docker will assume that, hey, this is not a URL. This must be in Docker Hub, right? Right now, we don't want that because our repository is on AWS. So we have to give the container an explicit, specific URL name. Where is this image going to be, right? So far, so good. Last command is we actually put. So this is the put command right there. So just like Git, if you've used Git before, right? You just say Docker push the name of the image, and then it will just send that up, right? I'm crossing my fingers that my internet doesn't cut at this point. But what happens here is that once you've pushed your container like this, done, cool. Almost done. There we go. So once it's pushed your image to the repository, you can go back here, just refresh this, and then you should see the image that you've just created over there, right? So far, so good, right? Now, that's a very, very huge step. Once you've pushed your container to a repository, I think that's the most important step you can do, because once the container is somewhere like this, in a repository like this, you can then reuse that. pretty much anywhere you want. You can use that container. Remember when we said Docker run, right? I was just running it on this machine. But what if I want to run it somewhere else, a different server, a different computer, a different machine, maybe I want to run it on this Raspberry Pi, for example, right? This is very important because now that you have your container image in a repository like this, you can then use that. The other places can then get your image from there, right? So if I have a server and I want to run that container image right there, I just have to tell that server, hey, your container image is right here on this repository, so that the server will just pull it. If you can push, then you can pull, right? Let's try that now. Remember, I said I'll show you 2 examples of how you can run containers, right, on AWS. One of the simpler ones is this service called, let me just give you a new tab, AWS App Runner. So it's a very, very simple tool. Let me show you how that looks. So AWS App Runner allows you to take a container. You just tell it, you just tell it where the container is, and then it will take care of everything for you. It will create the host. It will run the container inside. It will put a load balancer in front. It will make it accessible to the network if you want to, and so on and so forth, right? So remember, I created an API, right? An ASP.NET web API. Let's create that on the cloud right now. So over here on AWS App Runner, I just create an App Runner service. Like I said, this is the container image is coming from a registry. This is a registry, a repository, right? So like I said, once it's in a registry, you can reuse it pretty much anywhere. So you just have to say where your container is over here. So you can do this via a different repository if you'd like. But right now, this is the image I want. So I can just copy the URI like this over here, and then just paste that over there, right? And actually, that's pretty much it. So I just want to make sure that this is running. I'm using the right permissions. You can use an automatic deployment if you'd like. So every time there's a new image over here, your service over here automatically updates. So you don't have to worry about deploying it yourself. Right now, let's just keep it at manual because I want to show you how this works. So this is my container, manual deployments, just default role, just default permissions. Let's do that. Let's give this a name. This is my .NET SHA 256 API, right? Now, there's a lot of things here you can configure. Right now, definitely I have to change this because my service is listening on the port 80, just like any web server, right? Most any web server. Up to you if you want to configure anything else. At this point, we really don't need to. But up to you if you want to explore anything else here. Okay. One of the more important things I recommend you to check is auto scaling. I'll talk about that in a bit. But definitely, that's just what you need to do. Once you've provided a name and made sure the port is correct over here, let's just run that. Next, and let's just review everything, right? Deploy. So this is going to take, since this is the first time I've created a service, this is probably going to take maybe 3 minutes, 4 minutes. Every subsequent deployment afterwards should be a little bit faster. Okay, so while that's running, while that's like they're creating a service, right? I'd like to talk to you about some of the things. Whoops, where was that? Oh, here we go. So once your service is created, you will get a default domain like this. So AWS App Runner will give you your own domain URL like this, right? So you can access your application on this URL. So in my case, this is a .NET app. It's a web API app. It's listening on port 80. It has a hash 256 route. I could be able to talk to it over there once this is done, right? You can add in a custom domain. So if up to you if you want to add in a custom domain, right? Once this is also ready, you can also check the metrics for the service. You'll be able to see stuff like how many requests are coming in, is it experiencing errors, CPU utilization, how fast are your requests being serviced, and so on and so forth. All of those are pretty much done automatically for you. So you can actually work on that, run that pretty much kind of, your app already runs right away, right? So that's going to take a little bit, a little while. So while that's running, I want to talk to you about the second way you can run containers, right? The second example I want to show you. App Runner, this service is pretty good for like standalone apps. For example, I just have a simple website or a simple API like this, or I just want to run a container temporarily for like the next 30 minutes or 15 minutes, right? So it's a very, very quick way to run a container. For most applications though, you probably have something a little bit more complicated. You probably have a few containers running web servers. Those web servers are talking to API endpoints. Those API endpoints are also containers. They may be talking to some maybe databases that are also containers, and so on and so forth, right? So when you start talking about the microservices aspect of it all, something like App Runner isn't going to cut it. So it's App Runner is a little bit simple, too simple for something like that. So if you want to build more complicated systems, like something like a cluster, if you've used something like Kubernetes before, you'll know what I'm talking about. So if you have a cluster, you can run containers on it, for example. You can use a different service for that. And this is the Elastic Container Service, or ECS for short. So most of the customers I talk to, when they get started with containers, they want to know how to reliably manage and run containers in kind of like a production setting, in a complicated setting. So this is really one of my first recommendations most of the time. So if you have to run like a number of different fleets or groups of containers, ECS is a very, very simple way to get started with it. And the nice thing about ECS is you can pretty much use the same Docker tooling that you probably are already familiar with, right? Let's see if this App Runner is done before I get started. Okay, cool.
Yeah, all right.
Done.
I have a question myself.
Sure, go for it.
Yeah. Before we entertain it, I am seeing a new question in the comments now. But all right. At work we do use ECS, right? We have largish set of APIs and yeah, not all of them will be on microservices, and pretty much in our workplace in Page Shop, what we use is it's either ECS or lambdas. Basically, that's what we architect for. So those are two different things. What is it? It feels like App Runner is in the middle of those two, but I'm not exactly sure. So what is the use case for App Runner? Is it something simpler for more, I don't know, independent developers who just want a simpler setup without having to go through all the hoops of ECS, or don't go as granular as lambdas, or is it something else?
That's actually a really good question. So the thing you have to remember is that for something like Lambda, AWS Lambda is pretty much serverless functions, right?
Yep.
The thing with serverless functions is they cannot run indefinitely. So that's kind of the catch there.
Yeah.
So if you want to run a container for more than say, I think 15 minutes was it for
15
Lambda
minutes, yeah,
maximum?
that's the limit for Lambda. Yeah.
Yep. Then you really can't use Lambda to run your containers, although you can, right? You can run containers on Lambda, but you can't run it more than 15 minutes. So App Runner is kind of like you're right. It's a simpler, more straightforward way to run a container. If it's just standalone, it doesn't really depend on a lot of different other things. So yeah. Then ECS is more of a cluster kind of, when you have containers interoperating.
Yeah, it's exactly what it is. So I'm getting ideas now, because we would often get into problems like the Lambdas need time to warm up, right? So if we have a service that needs quicker, it's invoked several times, but not long enough that it doesn't shut down before the next service the next call comes in. We always get the problem of the startup time. So it looks like App Runner might be something to experiment in that. At least experiment in that sense, right? Interesting.
I actually really like App Runner.
All right.
Actually really like App Runner. Oh, there we go.
Okay.
So App Runner is already up. Let's try that.
Okay. But before we go to that, I think just a simple question from Pravin. Are you going to cover EKS?
I will touch on it, but I won't show you EKS, at least in this session. But I will give you a few pointers on where to get started if you want to know more about it.
All right. Let's go. Okay. Get on with it. Yeah.
All right, cool. So remember, we were running a container on App Runner, right? So now that deployment is done, our app is now on this domain. So as you can see, it's already there. So now if I do, as you'd expect, it should work, right? There we go. So now I'm running a container on the cloud. The nice thing about this is that it's pretty much a lot of the simple things you'd expect from running a container. You can also set up auto scaling for it, like somewhere here. There we go. So like for example, this one set for a minimum size of 1. But if it sees that this particular API is experiencing, for example, heavy traffic, a lot of people are talking to it, then it will automatically add more containers so that it can service the load automatically for you. And then once the traffic dies down, it automatically scales back in. So you're not spending too much money, right? So that's a very, very important thing that you can do for this as well. So App Runner, that's App Runner, a very, very simple way to get started with containers. Allows you to do auto scaling and allows you to do automated deployments as well. So I take a look at that once you have some time. Now, I was talking about ECS, which is more of a cluster-based kind of gig, right? I'll show you how that works. If you're familiar with something like Kubernetes, which is what EKS is, as Praveen was asking. So EKS is Elastic Kubernetes Service. It works pretty much the same way. You have a cluster. Inside the cluster, you can run pretty much as many containers, virtually unlimited containers as your cluster can hold, right? So this is very important for applications that have containers that talk to each other. So like I said, if you have a container for a web server that talks to APIs, you can have like say 100 different APIs and so on and so forth, all of those talking to each other in a kind of microservices fashion. You probably want something like ECS or EKS or the new ROSA, Red Hat OpenShift on AWS, right? I'll show you how you can use ECS very, very quickly because it's compatible with some of the common tools that you might be already familiar with. So if you've been working with containers before, you're probably already familiar with Docker Compose, right? So you can use Docker Compose to kind of orchestrate which containers run together in what quantity, which of those talk to each other, and so on and so forth. So let's do that now. normally, to create a Docker Compose configuration, you need a Docker Compose file, right? So that's what I just created. Save some time. I will again just paste some of my templates here. So in a Docker Compose template, you pretty much just say where your what your services are. Like a service is pretty much a collection of containers that run together, and how many copies of it. To specify where that is, you just say where the image is again. So let's just grab my ECR again. Let's copy that URI. I'll paste that in here. There we go. Right, same thing. And ports. So because my container is listening on port 80, I want to make sure that it's available on port 80, right? Something like that. Now, if I was on my machine like this, I can use that Docker Compose file to spin up an entire kind of cluster, let's say cluster of containers working together. So imagine if this was a more complicated compose file, a lot more images, a lot more containers, and so on and so forth. I can just say Docker Compose up, right? This is probably not going to work on my machine. Oh, it did. Oh, cool. So like that, it will spin up all of the containers that you need, right, in the same manner. So if I say, for example, let's cancel that. If I say, for example, on my compose file, I want to deploy this. I want you to create 5 replicas. I want you to run this container. I want you to create 5 copies of it, right? So 5 containers running concurrently at the same time. Docker Compose will do that for you. So you can do that. Oops. Yep, I can't use that anymore. So let's do that. Oops. Yeah, that's not going to work on my machine because I don't have a load balancer on my machine. Let's see how that works. There we go. So now, let me see if I can get you a glimpse into that. You'll see that I'm running 5 different containers, right? So Docker Compose is a very common tool that you can use to run containers in a set configuration. Like if you want to run multiple different containers that are working together in some way, multiple different containers, you can use Docker Compose to run them all together, right? Like for example, a web server, an API, and a database. You want to run all those 3 at the same time. Instead of running Docker run one by one, you can use Docker Compose to bring all of those up right away, right? That's pretty much it. Now, the nice thing here is that same Docker Compose up like that, I can use that to run my containers directly on AWS ECS, Amazon ECS. So over here, my Elastic Container Service, I can use Docker Compose to create a cluster, run containers, and so on and so forth, right? The same tooling that I'm already using, or you're probably already familiar with. So let's do that. Remember when I ran my containers, Docker Compose up, right? To run it on Amazon ECS, I just have to say that I want to run this on Amazon ECS. So normally that's just a context. So you say Docker, give a context, which is ECS, then compose up. And then this will automatically talk to AWS for you. So if you're logged in on your terminal, just like we did earlier, right? If you're logged into your terminal, it will talk to AWS on your behalf. It will create the necessary resources. Whoops. So something's wrong with my account right now, but so that's deleting. But what's going to happen is that it's going to talk to AWS on your behalf, and then it will try to run that for you. Now that's kind of deleting. Let's see if this works on a different region. Sometimes I use my Tokyo region for experiments, and that kinds of does all these unexpected things. But the point of the matter is you can use the same Docker Compose tooling to talk to ECS, Amazon ECS, and then create a cluster for you. Let's see if this will just, once that's done.
All right. I think while that's going, maybe we can entertain a question here from.
Sure.
No, it's from Acha. Which container is much better? Or I guess which container service is much better? ECS, Elastic EKS, container registry, or Fargate? Interesting question.
Yes, interesting question, definitely. Those services are kind of, you use them for different things. The most similar among those would be ECS and EKS, right? Most of the time, whenever we have a customer that wants to run containers on the cloud, their choice pretty much, most of the time, right? Their choice pretty much goes, is it ECS or EKS, right? My personal recommendation, at least, whenever I talk to somebody like that, is if this is your first time running containers, I normally recommend ECS because it's much simpler. There's you can kind of start up much faster. EKS is really, really nice if you want to get into the Kubernetes type of things, because Kubernetes in itself allows you to do a lot of different power things. But also, with that kind of power, that means it's also very, very complicated, right? So most of the time, I recommend for people starting out with containers, give it a try with ECS first. Then once you're more comfortable, maybe give Kubernetes a try, EKS, and so on and so forth. If you're already comfortable with Kubernetes, why not? At the end of the day, they'll run your containers.
Yeah, interesting. I guess that I also had that question in my mind about between ECS and EKS, and it's just I guess EKS is more flexible, in that you said it lets you do some more power things, right? in that sense there, right? Well, there's another question here, similar in the same, similar question, but it's asking specifically about data stores, I suppose, DB. So what is better, DB in a Docker Compose or just a separate container? Or maybe let's throw in Aurora and RDS there if we want to. But
cool.
What's your take on this?
Okay, so if you're running a database on Docker Compose like this, right? You have a Docker Compose file. What that will probably look like is you'll create a service, something like a database over here, and then you'll say where your image is, right? This is my database image latest, or something like that, right? If you're using Docker Compose to run a database in a container, you're still running a container. It's still a separate container. So it's not going to be like your API and your database are going to be in the same container, right? So they're going to be still different containers, whether you use Docker Compose or not. Docker Compose is just a very convenient way to run related containers together. So instead of you having to type in, multiple commands one by one, you can just use Docker Compose to do that. Now, I don't necessarily recommend running databases on a container. For a number of different reasons. Yeah. One of the technological designs of a container is that it should be very, very thin. It should be very, very ephemeral, which means that it's meant to be something temporary, right? If something goes wrong with a container, the general idea, the general philosophy should be, I should just, be able to throw that away, create a new one, and off I go, right? With a database, that's a very dangerous thing to do because you have your data. Yeah, exactly. So if you have your data, you throw away a container, you're also throwing away data with it, most probably, right? My general recommendation most of the time is that your databases consider first running it as a standalone instead outside of a container. Maybe like you said, Amazon Aurora or Amazon RDS, right? But yeah.
Yeah, very interesting question because one thing that comes to mind is the concept of servers as pets or livestock. You keep
Oh
you
yeah,
you you,
cattle or
you keep
cattle pets.
yeah. You keep your pets alive for a long time. You keep your livestock like disposable. So containers are meant for the livestock side. I think
Oh
the
yeah.
database is something that you keep for a rather long time. But great question. Vulpine, I don't know how to pronounce the Vulpine post. Yeah. And there he or she has a follow-up question even if the volume is mounted.
Hmm. So yeah, so when you say that you have a volume on a container, just for the people on the chat, right? When you say that the container has a volume, that means that you have like persistent storage. Think of it like you have a hard drive mounted inside the container, right? So that means that when you throw away the container, the data, the storage is still there because it's a hard drive, it's a persistent storage, right? So that's actually okay when you run a database, when you have to run a database in a container, right? One of the stronger recommendations we make is that make sure that your storage is, on a volume because you want your data to be persistent. So you can do that. Um, One of the things I still don't like about that is that most of the time, databases pretty much have to act like a single source of truth. Now, the idea behind it is that if you have containers that are really small, the idea of a container has to be very, very small. They're generally small, and they normally scale horizontally. If you need more power, quote unquote, right, with a container, you create more containers, right? That's the general way of going about it. Now, if you're talking about a database and suddenly you have a database in a container with persistent storage, suddenly you have a surge of traffic, a lot of different requests, a lot of different reads, a lot of different writes, most importantly, right? If you had 10 different containers all writing to the same volume bounds, right, then you now have a huge potential for something like race conditions and so on and so forth, because you now have a lot of these different containers talking to the same volume point. I'm sure that's, somebody much smarter than I am has probably already thought of that. And there's probably a good solution for that. But because of that reason alone, I kind of feel much better having my database run as a separate server somewhere else, not in a container.
Right. Right. Great answers. All right. I'll let you go. There's one more question in the chat, but Julian, I hope you don't mind waiting. I'd like Kartik to finish his, be able to finish his demo. Yeah. So let's continue with that.
No, that's all right. I'm still creating a cluster myself, so we can
Oh,
do
okay.
questions now.
Okay. Then let's entertain that question. What are the downsides of containers, since they're mostly used in the cloud nowadays?
Uh, okay. Really good question. So a lot of people tout about the benefits of containers. They're really, really nice. Don't get me wrong. They're very, very, convenient and easy to use. But one of the major downsides I think containers have is that unlike something like a virtual machine, right, which is a virtual machine would be something like I'm sure all of you are familiar with virtual machines, right? Unlike a virtual machine, the security boundary of a container isn't very well, it's not, let's just say it's not very, very thick, right? Containers, one of the downsides or caveats of containers, because it's thin, it's made to be very, very thin, it's made to be very, very reusable. One of the major caveats about it is that it's not as, the security boundaries of a container is not as solid, let's say that, as a virtual machines, right? And a lot of people that don't know that sometimes accidentally create containers or container images that have security holes, for example, that leak some of their secrets, for example, leak some of their secret access keys, tokens, and so on and so forth. So it's a very kind of, that's one of the, I think that's one of the really major downsides of a container, at least when you're using containers. So it's good that you ask that now, especially if you're starting with containers, just so you are aware that, that's a thing. So you have to be, you have to be wary whenever you create a container, or at least wary about that kind of detail.
Right. Great, great question. Thank you so much, Julian. Right. Something's going wrong with my feed, I think. But yeah. So let's continue with the demo, I suppose.
Sure. Let me see if I'm actually, there we go. So what I've done is, so something's wrong with my Tokyo region. There's something running in my Tokyo region that's a problem. So what I've done is I've created this in the Singapore region now. So this created correct. So just to show you that, I'm not pulling your leg again. This is just Docker Compose up. I've created I've set it up in the Singapore region this time. So this time it worked. So what you can see now is, whoops, let me just, there we go. So this is what I was showing you earlier. Amazon ECS, right? Because I created the cluster, it's right there. Remember when I went to, where is my Visual Studio Code? There we go. So this is my compose file. This is my Docker image. And then I ask it to create 5 replicas like that. So you can actually go to ECS and go into this cluster, and you'll see that it's created one service, which is that, right? Services API. And then inside that service, it's run 5 different tasks. So a task is pretty much just a collection of containers that run, together. So right now, I should be able to scroll down, right? There we go. So I now have a cluster running that service with 5 different containers, right? And maybe just to see what happens, let's try. Let me see if I can do this. Huh? Let's try bumping that up to something like 8. What happens if, how do I then update my cluster? So that's kind of the question there. How do I then update my cluster? What if I change a configuration somewhere? What if I change the image name? What if I want to add a new service, right? Like for example, here, I'm running more containers. I'm adding more containers. So from 5, I wanted to do 8. Well, the good news is I just have to run that again. I just update my compose file, right? And then I just run the same thing, Docker compose up, and then it will talk to AWS. It will talk to AWS account. It will figure out what needs to change. So the communication is something like, from my machine, he's telling AWS, hey, this guy, he wants to run 8 containers now. How many do you already have? And then AWS will say, oh, there's already 5. And then, oh, okay, I need to run 3 more then. Okay. And then they'll just kind of, coordinate that between themselves. So you'll see that there, like that. Now what happens is that over here, you'll see my cluster's already updated. Now it's updated that, hey, this cluster, I want 8 tasks. I want 8 replicas. I want 8 copies of that container. Right now, there are 5. So then the cluster will then react, right? It will do everything it needs to do so that you get your 8 containers. And then, it will take a bit of time, but you'll see that coming into play in a bit, like that. See? So it should be here. So that will deploy in a bit. Cool. So the point being is that Amazon ECS, it allows you to run containers together in a kind of cluster configuration. So you can probably imagine if this was a real production system, I'd probably have an API. I may have, like just I showed earlier, I may have a database somewhere. I may have, say, a web server somewhere. I may have, data processing jobs somewhere, and so on and so forth. And then I can just deploy all of those into my Amazon ECS cluster using Docker Compose, which you probably will already be using if you're working with Docker. So that's kind of an easy way to get started with ECS. Oh, there we go. So now my tasks are up and running, right? So I can actually see that, hey, I have, whoops, where is that? I have a deployment. There we go. So my deployment, this is my initial deployment. 7 minutes ago, I said, create this cluster, run these 8 containers, and so on and so forth. The nice thing is you can actually see metrics like how well are your containers running, how much resources are they using right off the bat. So you don't have to set, pretty much you don't have to set anything else up. You can just see all of those right away. Then you can see that in something like, maybe if you want to see that in a visualizer like Grafana or whatever you're using, you can kind of just put in the graphs there, right? Anybody have any questions so far? Let's see if we can talk to this service. There we go. So here are your tasks.
I don't see any questions at the moment, so I guess we could continue.
Okay, that's fine. So that's pretty much how you get, I showed you 2 different ways to get started with containers on AWS. So I showed you App Runner earlier. It's a very, very quick way to run a container with auto-scaling, automatic deployments. Pretty much, it's a very simple way to get started with it if it's a standalone application, for example. If you need something a little bit more complicated, like containers working together, different kind of containers working together, ECS is a really good way to get started as well. So you can create an Amazon ECS cluster just by using the Docker Compose CLI tools. If you're already familiar with how Docker Compose runs or is used, or how you can use it, then you can use Amazon ECS. Okay. Cool. I am not going to explain every single container service in AWS, but just to give you a better idea of the options available for you, I earlier showed you ECS right there. That's the first one right there. So that's one of the container orchestration services in AWS, right? We also have EKS, which is the Elastic Kubernetes service. If you prefer to use Kubernetes for your containers, you can use EKS. Both ECS and EKS have an anywhere version. So ECS anywhere, EKS anywhere. This allows you to run ECS or EKS on your own machines. So if you have like servers at home or in the office, or you have a data center of your own, you can run ECS or EKS there. There's also EKS distro, which is the open source version of our Kubernetes, right? So you can run that as well if you'd like, if you want to do most everything yourself, right? We also have ROSA. I mentioned that earlier, which is Red Hat OpenShift service on AWS. So if you prefer to run OpenShift, which is kind of like a Red Hat version of Kubernetes, we also have that if you'd like to do that. And AWS Proton, which is kind of a mix between containers and serverless. So if you want to mix a lot of different containers and serverless together, which you normally do in a lot of microservice kind of architectures, AWS Proton is also a good contender or a good alternative. Not going to go through a lot of the other things, just so you know, there's a lot of different other tools on AWS that you can use for containers that allow you to use containers. I've shown you App Runner, right, which allows you to run containers in a simple kind of standalone fashion. ECR, which is the container registry, Elastic Container Registry. It allows you to store your images so that you can reuse your images everywhere. like for example, other service, right? We've mentioned Lambda earlier. There's a lot of different other services that you can use on AWS for containers. A lot of those have very, very nice uses. Like for example, Copilot right there. It allows you to talk and run containers a lot like how you'd use Docker Compose, but in a much more, I guess, involved fashion. It allows you to do a little bit more. So I really, really like that. So if you have some time, take a look at Copilot as well. That's something I really, really suggest. Where do you go from here? If you want to know more about containers, we have a dedicated containers portal on AWS. So right there, that's the link to that. We have a lot of information about how you can learn about containers, use containers on AWS. A lot of the information I gave you today are pretty much, like I said, very, very high level. If you want to go deeper into what else you can do, there's a lot more information in this URL. Finally, if you want to just, run classes, take classes, learn more about technology, different kinds of technology, not just containers, maybe machine learning, maybe IoT, serverless, and so on and so forth. We have a dedicated site for that called AWS Skill Builder. You can come on here. There's thousands of digital self-paced trainings and learning material. So you can just subscribe to any of the learning material you want to read or practice on about, and just learn at your own time, right? Continuous learning and continuous improvement. Okay, that's pretty much all the things I wanted to share with you today. Thank you for having me.
Thank you so much, Carding. Thank you for that really, really insightful talk. All right, so we still have a few questions here. The first one is from Sanmi. Where can we get code for this demo? Do you have a sample repository anywhere? GitHub probably or something like that?
Yeah, I'm actually working on publishing the code I just showed you earlier, but I just couldn't make it in time. So I'll work with John right after this. So
all right,
I'll share that through you.
All right. So we'll make sure to, if you have registered to the meetup groups, we'll post it there, and probably we're also going to post it in the fb.com group if you're also a member of that one. And then Praveen also has another question. Can you please also talk about a pricing model for ECS versus EKS? I guess that's a question about pricing. Which one is more expensive? Which one is cheaper? Which one? How does it work?
No, that's a good question. So there's a bit of detail with the pricing, but just to give you an idea of how it works, whenever you're talking about orchestration, container orchestration, you normally talk about the control plane and the data plane, right? So the pricing for ECS and EKS is pretty much the same. So if, for example, you have a data plane that has like 3 nodes or 3 hosts with the same size, the same number of CPUs, the same amount of RAM, the pricing for that is the same, right? ECS or EKS. What they differ on is the control plane pricing. So for ECS, the control plane pricing, there's no costs involved with the control plane. That's also one of the reasons why I normally recommend ECS first, so you can try it, much more easily. For EKS, we manage the control plane for you as well, but there is a cost involved. I just don't remember the right number right now, but it is hourly based pricing, I think.
All right, thank you very much. So yeah, I guess there are no more questions. So thank you very much, Carding. Any parting words for us, or any message to everyone here?
Well, just really thank you for having me. One of the best pieces of advice that somebody's given to me when I was, a much younger engineer is just, never forget to continue learning. Especially in our field, especially in IT. Everything moves so fast, right? So like what you know today, 2 weeks later, it's just probably something new, right? So don't forget to keep on learning. Sometimes it gets complicated, but there's always communities like PHINUG that you can go to ask for
Mhm.
help and ask for assistance, right? So don't be shy
Absolutely.
about it.
Absolutely, absolutely. It's great that you pointed that out, because I don't know if people noticed our event poster. It actually contains a bit of a reference to the 20 years of .NET that we're celebrating this month. And yeah, I'm old enough to remember .NET as this new technology that I didn't study at school, that I have to learn at work. I'm that old, so
Oh
yeah,
wow,
yeah, yeah. So,
happy
so,
20
so,
years.
and now it's 20 years later. So yeah, it's just awesome, and that there are venues like this, right? That we can share our what we know, and also learn about new things. There's a ton of things that I still don't know about AWS, even if I use it at work, for example. So yeah, so thank you very much for imparting your knowledge here, Carding.
No problem. It was my pleasure.
All right. So with that, we'll say goodbye to you uh for now. All right, and
No
hope we
problem.
see you back again so some other time. All right. So thank you
I
very
hope so too.
much. All right. Cool. So thank you very much, Carding. All right. Now, before we continue, I'd like to share this QR code, and just like to ask everybody to please scan this QR code, and yeah, we appreciate your feedback. Please tell us what you thought about this talk. If you don't have any something to scan it with at the moment, the actual URL is down here. How the Yeah, I'm not sure how to make those two things not run over no over each other, but yes, we'd like to hear from you. We'd like to hear what other topics that are related to both .NET and AWS that you want to see in the in this PHINUG online session. So yeah, your feedback will be very much appreciated. Again, I'm showing that code, and then I think we forgot something. Carding, are you still there?
Absolutely.
I like to add you to this stream again. We have we I think we have several promo codes here from for AWS that we were meant to give away. Yeah, so how do we do this? Do we just do we just give it away to our to our audience who had asked their really good questions?
Yeah, I'd say let's give the really good questions some credit codes.
But yeah, one of them would be Praveen, who had asked
Definitely
quite
Praveen.
several questions. So thank you very much. The other one would be Vulpine Post. The other one would be I think Julian Uy from I'm not sure if that's Julian Uy from you. Sorry, I was saying Uy. It's Julian Yu from on Facebook. We couldn't show it. We couldn't display his name here. So for them who I had mentioned, could also include Acha, but yeah, let's see. But for those who had I had mentioned, I I'd request you to please reach out to phinug at live.com.ph. That's the email address of Phinug. Otherwise you could send me a direct message. Or the um Oh, I think the better place to send it to would be Let me see if I could just flash our social media channels. So please, um send us a tweet, or send me a message over on meetup.com, and we could share with you those promo codes that you had won. So that's Praveen, Vulpin Post, Julian Yu, and I think they had asked the really insightful questions tonight. All right, that's it. Thank you very much, Karding.
Thank you.
All right. So that concludes our PHINUG online live session today. That was brought to you with the cooperation of AWS Siklab Pilipinas, and AWS User Group PH. So yes, please again, we'd request you to provide your feedback in the URL flash below. Hopefully you got the QR code earlier. You could also rewind that. There were a lot of people asking if this would be recorded. Yes, this would be recorded in the same YouTube URL right after this broadcast. So I think it takes about 5-10 minutes before it gets there. So just refresh it, and you would see the broadcast recorded so that you could review it. And of course, we would be sharing the sample code that people had been asking for in our social media channels. With that, I'd like to thank everyone who was in the live stream. Thank you very, very much for being with us and for participating. Next month, we will have somebody from Microsoft this time, and to talk in our March meetup. So we're fixing that up. Stay tuned in our meetup.com channel or page. Join PHINUG, join the Philippine.net users group in meetup.com. Also join the .net virtual.net users group, and you would see the invite there once it is ready. I won't share yet who it is, but yes, somebody from Microsoft will be joining us. That being said, thank you very much. Magandang gabi sa inyo lahat. Maraming salamat. And thank you and good night. Hope to see you next time. Goodbye.